All right, so this will be, hopefully I can get through all of this as part 2 here, okay? I think we're only going to really go to example 7 there. Okay, so what I want to do here first is just rip through example 3. What this is saying, okay, it's important for you to keep in mind, or at least have the wherewithal about, what is it they're graphing? It's y versus x. So it's just the function. It's the function f of x that they're plotting here, right? Now, this question wants to know, where is the function positive? Where is its derivative positive? And where is its second derivative negative? So in other words, where is the area positive, the slope increasing, and when it is concave down? Okay, these are the 3 things you're looking for. Okay, so the area, which point would be concave down, have a positive slope, and have like basically a positive, or be in the positive portion of the graph. Well, it looks like everything from D on to H would have negative slope. Okay, so that would be an option for, I don't know, a later questions with anything with negative slope. Okay. And the positive slope piece would be, I don't know, anything from either A, B, C, or I, J, or K. Now the thing is we're looking for, it has to be above the x-axis, so we can't, it's not going to be any of these guys, right? Could be K, but K is not concave down, so that just really narrows down the fact that it's point C. Okay, C checks off all of these situations here, right? C is as a positive y value, it's increasing at that point, its slope of the tangent is increasing at that point, and it's concave down. Okay, for B, it's looking for, again, above the x-axis, decreasing slope, and concave down again, right? So where is a point that does that? Well, we identified, the decreasing portion of the graph is going to be anywhere from D to H, right? And it looks like a point that would be negative and concave down could be point E. Okay. For C, we're looking for a point that is below the x-axis. Okay, so either we're looking at A, H, I, A, H, or I, it looks like. Okay, and then the derivative has to be positive, so increasing. Well, that could be A. H's slope would be 0, so that's not helpful. So now we're down between A and I. I would say I is increasing in slope, and it's also its second derivative. We want this to be concave up. Well, that looks like I. Okay, I would be concave up. Okay, now for D, graph below again. Okay, slope is equal to 0. Okay, well, we already identified the fact that H, the slope, was going to be 0, right? So that's a candidate. But then they want the fact that the second derivative is going to be less than 0, so that would indicate concave down, right? Well, H is concave up, like its second derivative, y double prime, should be greater than 0 because it's opening up. So this doesn't exist. There's none that fit this criteria there. Okay, for point E, we want it the point to actually be 0, so we're on the x-axis, B, G, or J. One of those 3 points we're going to have to decide through or by, right? And we want its slope to be increasing. Well, that eliminates G because the slope of G is negative. So that's either we're at B or we're at J. The slope is positive. And then we want concave down. Okay, sometimes the concavity is a little difficult to see, but you can see here, you know, this is, we're making the transition to concave down. Okay, as opposed to something like this. This is making the transition to concave up, right? The curvature of the graph there is concave up. If you, you know, if you were to blow it up, right, really close. So this here, we're looking for concave down. Well, point B is concave down. Okay, and the last one, positive x value, or sorry, positive y values decreasing, and second derivative is equal to 0. Well, this means we have a turning point, right, or point of inflection. That would be a point of inflection, or where we're switching from concave down to concave up, would be at point F. You can see how we have to make the transition between concave down and then coming to concave up. Okay, and that transition point is going to be point F. Okay, so hopefully that we could also hear inflection point, I suppose. Okay, that hopefully that locks in some ideas about concavity and slope, and relating the actual function itself. It's sometimes just be careful in what they're actually graphing, right? We've seen that a couple times today already, where, you know, make sure that they're not plotting. We're going to see this down here, you know, the derivative function or the second derivative function. Okay, so for example 4, we want to sketch a graph of a function that satisfies the following conditions. Okay, so we want the second derivative to be greater than 0 on the interval x less than 2. So that means we want the graph to be concave up for x greater than 2. Okay, and then we want the second derivative to be on the interval. What's going on here? Oh, sorry. On the interval x less than 2. Sorry, it's concave up. Sorry. And on the interval, I don't know. Sometimes this maybe helps as a new concept. Concave up, concave down, right? On this interval, and then specifically we want the point 2 and 0. It's going to go through that point, and then we want the slope, right? Slope, it's increasing when greater than when the okay, everywhere that the value of the graph is greater than 2. Okay, x is 2. Okay, it's gonna be increasing. Okay, so we're just gonna try and plot this down. Okay, and let's create an interval table again. Okay, if we're ever asked to sketch something, we're gonna draw our intervals, right? Well, we don't need a colon. We can just draw this. We can say, okay, well, on the interval x less than 2, on the interval x equals 2, right? Because that's what it's telling us here, and then on the interval of x greater than 2. A little tricky to read this stuff sometimes, right? Which I find is what's helping me a little bit is writing some of this stuff down underneath, right? So that when I go back, I can actually make sense of this. Okay, so the original function, right? You're going to try and fill in all the information that they've given you on this graph, or in the like information provided in the question, right? So you can only fill in what you actually know, but then you could sketch it accordingly. Okay, so when the second derivative, we want the second derivative on the interval of x less than 2 to be positive, right? So concave up. And then we want its derivative here, second derivative on the interval x greater than 2 has to be negative. Okay, which tells me somewhere in the middle, we're going to have this inflection point. There's 0. Okay, Okay, and then then we also know we want the slope, right? It told us the slope has to be increasing, so positive, when at x equals 2. And then we know that this is going to be, in the function itself is going to be concave up and concave down. Okay, and then we can go over to our graph and figure out, here's 1 and 2. We know the slope here has to be increasing, right? And then we know for a value x greater than 2, just on the other side of x equals 2, the graph is going to, sorry, I shouldn't draw that as a straight line. We're going to try and do something like this, right? The graph's going to go like this. It's going to switch. It's going to make the transition to concave down. Okay, and this point here is 2, 0. Okay. So we know one other thing here. Sorry, I'll add in the fact that this is a POI, or a point of inflection, right? At 2, 0. Okay. So let's jump down here, and this is an example where they've told you just be careful with what they're telling you. Okay. So they want to ask you a series of questions here. On one intervals is the graph of f of x concave up. Well, just pay attention to what it is they're actually graphing with this first graph, right? They're giving you a map of what that second derivative actually looks like, right? And it's telling you that below -1, so for x values less than -1, we're going to have a negative portion of the graph. Not dealing with slope, right? We're saying that we're going to have concavity of up or down depending on which portion of the x values, right? So for x is greater than -1, we have a positive value above the x-axis, which tells me this is going to be concave up here. Okay, we're dealing with the actual values, the y values of this graph, not the slope. Okay, and then y values on the left side of -1 are going to be negative, so we're going to have concave down over here. Okay, so we can write that in over here. So we can say y double prime has to be greater than 0. So that's on the interval concave up is going to be on the interval of x is greater than -1. And concave down, y double prime has to be less than 0. Okay, so x is less than -1. Okay. Then we have two situations here, right? We want to list the x coordinates of all the points of inflection. Okay. One of them is at x equals -1, right? We know that. That's when the graph is switching from, oh, not one of them. It is that one, right? We only have one. And that's because we're making the transition between negative values of f double prime and positive values of y double prime, right? So this is where y double prime is equal to 0 specifically. Okay, sorry guys there. So just 1 point. Okay, y double prime equals 0, right? The value of the y double prime graph is 0 there, right? Which that denotes it as being, this meets the definition that we discussed earlier, right? That tells us that that's an inflection point, specifically because y double prime is 0. Okay, and if we wanted to make a rough sketch of this thing, and we could assume that when x, the point x, y, we're going to see that that's going to be 0, 1. Okay, so we know it's going through that point. So we can go plot that one, 0, 1. And then from there, we're going to try and like fill in our intervals. Okay, and so we know if x is less than -1, we're concave down. And if x greater than -1, we're going to have concave up. Okay, so those are the only two conditions that we really have here. So we just go draw those. Okay, so we know from x is -1, we know that the graph has to be concave up. And for for x is less than -1, we know the graph has to be negative. And so it fits part B here. Sorry, here I'll draw this. It fits part B in saying at x equals -1, the second derivative is going to be equal to 0, which tells us that this is an inflection point. Okay, I'm going to hit stop there because I've been talking quite a bit there. I'll hit stop and then we'll pick up the last couple of questions here in part 3. Okay.